Metricon 2010, the film thickness measurement system using the phenomena of Prism coupling. This machine has two wavelengths, a helium neon laser 632.8 nanometers and an IR laser 1551 nanometers. The knobs in the front here are actually the shutters, and at any point of time rotating them vertical, the label being vertical, the laser is blocked, and then when you mark when the label is horizontal, the laser beam passes and reaches the prism coupler. To install the sample, there is a piston actuated cylinder here, and there is a switch on the left hand side. This is a pneumatic switch. Adjust the pressure about 35 psi. A pressure range between anywhere 25 to 45 is good, but too much pressure could break the sample. So the surface of the sample should be clean, and also the prism. They should be particle free, and once you clean it and turn on the pneumatic switch, placing the sample right on the prism. Now once the sample is aligned and the sample is placed in it, you have to close the shield so that the scattered laser light is not shooting outside. These two micrometers here are attached to a final reflecting mirror which shoots both the lasers to the prism coupler, and there are two sets of mirrors in front of each laser source which control the beam positioning onto the third mirror. While changing a laser, those two mirrors should be adjusted, but not the top two ones. And depending on the usage, over time these micrometers may have to be fine-tuned in order to get a best result. The system is run by a PC in DOS mode operating system, and the application software pops up as soon as the system boots up. There is a prism coupler controller here which drives the motor holding the prism. I'm going to run a reference test now. So the motor spins first to the limit switch while doing a reference, and then once it hits the limit switch, then it will start scanning. From the parallel port of the PC, there is a printer attached, a thermal printer, which will print both the plot and the graphics. The helium neon laser power supply is attached to the shield in the back, and the diode laser, the IR diode laser, runs with a 9-volt DC power supply. And there is a small meter here which indicates the signal level, and there are ports on it for offset and gain. And the black knob here, when rotated, will move the prism table either in positive direction or negative direction. So right now on the screen I have selected substrate refractive index measurement, that is F9, and I'm going to make an automatic measurement. So the gain needs to be adjusted depending on the type of laser we are using. Every time a sample is changed, a minor adjustment to the offset and gain would be necessary. Point of time, pressing escape key opens up the configuration screen, and here we enter the values such as substrate index if we are using a film coat deposited on a silicon substrate or any other substrate, and then prism code. Every prism is marked with two codes on both top on either sides, and every time you mount a prism on the table, whatever code is vertically up, you have to enter it here. And then the start scan and stop scan. These are the limits up to which the prism table will be driven on negative end and positive end. And the wavelength. The wavelength can be selected by going to the access screen. There are three possible wavelengths for this machine. And then the prism index, TE prism index and TM prism index values are written here. For different prisms, you can enter those. And the print format, there are three types of print formats exist. And the system could be also programmed. Three keys can be programmed to do any kind of actions. Now the access code here is access. Once you type in access, the second prism configuration screen opens up. The prism coupler's second configuration screen. In this one, there are different other parameters that could be selected, and the three available wavelengths are here. Anytime a laser is changed, the IR laser, the particular wavelength can be entered here. So just use up and down arrow keys to move from one location to another. So escape key will take you back to the original screen. And now, first, there is a key here, home key. Every time the system boots up, the system will automatically do the referencing. Otherwise, whenever the wavelength is changed, the prism coupler table referencing is to be done. Press the F1 key. All the function keys are programmed for the known operations here. This one is for substrate refractive index measurement, and then for changing T to TM mode, which are pneumatically activated, pressing this key here will help, that is F11. As soon as the PC boots up, it will open into the application program. And the system is connected to a thermal printer, and there is a meter that indicates the signal level. And the prism table rotates, which is powered from the prism table controller. So depending on the signal level, I'm adjusting the gain and offset here. And once, it has to be done a couple of times in order to see the modes if we are measuring film thickness. But if we are doing the refractive index measurements, you have to increase the gain a little bit. If there is any dirt on the prism or the substrate, the signal will be a horizontal line. So at this point, the system did not find the need, probably had to clean the particles here. So I'm going to try one more time before I clean the substrate. So I cleaned the substrate and adjusted the gain and offset. So I got a signal here for the substrate refractive index measurement. The system located in the at -177 and substrate index is 1.45694. To repeat the measurement, we can enter a sample ID and press F1. So this system should be operated in a good clean room, and people should wear gloves while operating. So the upper line here indicates the table position, and after the scan it will also indicate with a blue cursor the cursor position. Yep. And this is the refractive index at that point and the intensity level, and this is the measurement here. I'm going to now change to the second wavelength. So first I close the shutter for 632 nanometer and I open for IR, and then I should not forget to change the wavelength in the configuration screen of 1551 nanometers, enter, and then I go back, and before I proceed, just in case, I will do the referencing again. F1. So these two peaks indicate that the system found the reference, so that the alignment is perfect. Okay, this is a plot with the infrared laser, 1551 nanometers. I'm going to run it at one more scan. The IR laser is very intense, so it seems it is more intense than the helium neon laser, so I had to reduce the gain a little bit. So at the substrate index where the knee is located at -114, the substrate index is 1.44538. And in order to print this, we use print screen button, and the system will ask prompt, do you wish to print? So once you say print, the system will start printing. Unloading the sample. This time I want to measure a film which is about 9,400 angstroms on a silicon wafer. And after installation, now I'm going to use the helium neon laser first. I'm not adjusting these micrometers at all. So anytime you're changing the wavelength, the micrometers need not be adjusted. Only at the first time installations they have to be adjusted. I'm referencing for the helium neon laser again, just in case. And I have a So right now the helium neon laser is on and the system is sampling. And so the thickness measured is 9,456 angstroms. And these are called the modes, and system, whenever it finds more than 2 modes, is good. The refractive index is calculated and also the standard deviation is evaluated. Several mathematical calculations are possible. The manual includes all the procedures, and sometimes if the signal goes above this scale indicated by I here, then we have to reduce the offset, and right now I can show how to do that. I'm moving the table and I'm changing the offset, so the offset change shifts the signal. We can also increase or decrease the gain, and anytime you want to abort this measurement, you press escape only once. So the number of modes are dependent on the wavelength and the thickness of the film. Now I'm going to measure the film thickness using the second wavelength, which is IR wavelength. So first, I'm going to change the parameters, the configuration screen. So it indicates that only one mode is found, and when only one mode is found, the system will prompt to give an option whether you want to measure thickness or refractive index. So if the refractive index is known, this is the question here. If the refractive index is known, you can enter T, or here in this case I know the thickness, so since it is a piece of a standard wafer, so I want to measure the refractive index, so it asks for the assumed thickness, which is 9,470 angstroms, and you calculate the refractive index 1.439, which is well within the limits. The pneumatic connector here has a small needle valve, and there is a pressure regulator for adjusting the pressure with a gauge. There is a green ground lead that is to be connected to the chassis of the system, which is attached to the Prism coupler's power supply. All the connectors will be labeled and marked, and there are 3 connectors that go in B, 1, 2, 3 positions, and a ribbon cable on the Prism coupler power supply. And this is a 9-volt power supply for the IR laser, and this is the milliscrew power supply for the milliscrew helium neon lathe.